Alright, so we're looking at case 2 of finding limits algebraically. We've plugged our x value a into our function, and we get a 0 in the denominator, but a non-zero number in the numerator. And so here would be an example of a limit of that type. The limit as x approaches 2 of 3 over x minus 2, where we get 0 in the denominator when we plug in x equals 2. So let's take a look at the graph of this function. So it's a function with a vertical asymptote at x equals 2. If we approach 2 from the right, we're going to see the function going to positive infinity at the vertical asymptote, and if we approach 2 from the left, we're going to see the function going to negative infinity at the vertical asymptote. So the answer to this limit problem is that it does not exist, because in this case the left limit is not equal to the right limit. This is common, a common occurrence when we have vertical asymptotes for the left limit to not equal the right limit, but we do want to note that as long as the function is defined on the left and right side of the vertical asymptote, we can almost always, or I'd say always, find the right limit and the left limit, and these right and left limits are going to be either plus infinity or minus infinity. Let's look at one more case of 0 denominator and non-zero numerator. Okay, so in this case, we're again approaching x equals 2. We get a 0 in the denominator, a non-zero in the numerator. Notice that we've got the denominator squared this time. So let's take a look at the graph and see how it differs from the first graph we had. Okay, so we still have a vertical asymptote at x equals 2 because the denominator is still 0 at 2. However, when we approach 2 from the right, we go to positive infinity as before, but when we approach 2 from the left, we again go to positive infinity. And so in this case, there being a common left and right limit, we are able to give a value to this limit of positive infinity. So summarizing what happens in case 2 is that we can always determine the left and right limits at the vertical asymptote as long as the function is defined. They are either going to be plus infinity or minus infinity. When they are not common, the limit does not exist, and when those two left and right limits are common, the limit does exist, and they're common. The answer to the limit question is their common value. All right, that's the examples for case 2. We're going to, in the next video, start looking at case 3, which we divide into a couple of different segments.